Hello and welcome. Our task for today is to find the value of this quantity, x raised to power 4 plus y raised to power 4. Given that x plus y is equal to minus 2 and x raised to power 3 plus y raised to power 3 is equal to 16. I was able to solve this question in two different ways and I will share both of them with you in this video. But I'd be glad to hear from you if there are other ways to tackle this problem. Please do let me know in the comment section. Now, the first way I solved this problem was to solve the two simultaneous equations, get values for x and y, and then evaluate this quantity. This was what I did. First of all, you can see that this is the sum of cubes, and you know that we factor the sum of cubes as x plus y into x squared minus xy plus y squared, and of course this is equal to x raised to power 3 plus y raised to power 3. But we know that this is minus 2, so we have minus 2 here into x squared minus xy plus y squared, and we know that this is equal to 16, so we have 16 here. Opening the bracket, we have minus 2, or rather, before we open the bracket, we can actually divide both sides of this equation by minus 2. So we have that x squared minus xy plus y squared is equal to 16 over minus 2, and of course that is equal to minus 8. Now here is where we consider the first equation. From the first equation, we have that x is equal to minus 2 minus y. So we can replace x in this equation with minus 2 minus y. So doing that, we have minus 2 minus y squared minus 2 minus y multiplied by y plus y squared is equal to minus 8. Opening the brackets, we have minus 2 squared, and of course that is 4. Here we have 2 times minus 2 times minus y, and that is plus 4y. Next, we have minus y squared, and that is plus y squared. Here we have minus 2 times y, and of course that gives us minus 2y. But because of this negative sign, we have plus 2y. Next, we have minus y multiplied by y, that is minus y squared. Once more, because of this negative sign, we have plus y squared. Then we have plus y squared, and this still remains equal to minus 8. Now we collect like terms. We have y squared, we have 2y squared, and we have 3y squared. So we have 3y squared. We have 4y, and we have 6y. So we have plus 6y. Now, the only other constant term is over on the right-hand side. So I think it will be best for us to take this 4 over to meet minus 8. And of course, this is plus 4. Going over the equality sign, it becomes minus 4. Minus 8 minus 4, of course, is minus 12. But now we can divide everything by 3, because you see that we have 3 here, we have 6 here, and we have minus 12. So that gives us y squared plus 2y is equal to minus 4. We have a quadratic equation, and we can solve it by completing the squares. The constant term is already on the right-hand side, so the next thing we do is to add the square of half the coefficient of y to both sides of this equation. Now, the coefficient of y is 2, so half of it is 1. So what we are going to add to both sides of this equation to complete the square is 1 squared. So we have y squared plus 2y plus 1 squared is equal to minus 4 plus 1, because 1 is 1 squared. Now we take 1 of y, we take 1 of this, we square, and this of course is equal to minus 3. So we have that y plus 1 is equal to plus or minus square root of minus 3. And this is y plus 1 is equal to plus or minus square root of minus 1 multiplied by square root of 3. This is equal to plus or minus I, because you know that the square root of minus 1 is I, root 3. We have that y is equal to this going over. We have minus 1 plus or minus I, root 3. Now, to find values of x, we remember this equation. So we have that x is equal to minus 2 minus, we have that this is y. So we have minus 1 plus or minus I, root 3. This is minus 2. Minus minus is plus. Minus plus is minus. Minus minus is plus. And of course, this is I, root 3. Minus 2 plus 1 is minus 1. So we have that x is equal to minus 1 minus or plus I, root 3. So now we found values for y and for x. Now the next thing is to calculate x raised to power 4 and y raised to power 4, add both of them and get the value of this quantity. But before we do that, let us look at the values of x and y that we calculated. We can see that when x is equal to minus 1 plus I root 3, y is equal to minus 1 minus I root 3. And when x is equal to minus 1 minus I root 3, y is equal to minus 1 plus I root 3. So what does that tell us? It tells us that whatever pair of x and y that we choose, whether we choose the first pair or the second pair, that the value of this quantity that we calculate will always be the same. So now let us choose the first pair. Now, we can either raise x and y in their rectangular form. The rectangular form of a polar number is the form a plus ib. That is in this form where you have a and b as real numbers, because we can see in this case minus 1 is a real number and root 3 is a real number. In this case, minus 1 is a real number and root 3 is a real number. So we can either do this and this in this way, expand them algebraically and get the value for this. Or we can change x and y to the polar form of a complex number. The polar form of the complex number is the form where r is the modulus of the complex number and theta is the argument of the complex number. We have the modulus and the argument are very easy to calculate. So the best thing for us to do is to change both y and x to its polar form, and you will see why I said that it's the best thing for us to do. So without wasting time, let us change x and y to their polar form and then calculate this and finish the computation. So to change x to its polar form, we have to represent x on the complex plane. Now, this is the axis for the real number and this is the axis for the complex number. So here we have minus 1. We have minus 1. And here we have root 3. So we have root 3. Now, this is the complex number. And the modulus, that is r, is the distance from the origin to this point. So this is r. But notice that this is a right-angled triangle. This side, of course, is root 3 and this side is 1. So to calculate r, we simply have to use the Pythagoras theorem. So we find that r is equal to square root of minus 1 squared plus root 3 squared. And this is equal to square root of 1 plus 3. This is equal to square root of 4. This is equal to 2. You can see why I say that it's very simple to calculate. So already we have that r is equal to 2. Next, we calculate the argument. The argument is the angle that the complex number makes with the positive x-axis. That is this angle. But let us calculate this angle. Let us call it alpha. From the right angle triangle here, we can see that tangent of alpha is equal to opposite over adjacent. That is root 3 over 1. And from here, we have that alpha is equal to arctan or inverse tan root 3. And this is equal to 60 degrees. So this angle is equal to 60 degrees. Therefore, theta is simply equal to 180 minus 60 degrees. So this is 180 minus 60 degrees. And this is equal to 120 degrees. Now you can see why I say that they are very easy to calculate. So now we have that the polar form of x is equal to 2 into cos 120 degrees plus I sine 120 degrees. We come over to y. Once more, we represent y on the complex plane. Here we have minus 1. And here we have minus root 3. So we have minus root 3. So the complex number is this. Remember that this is still r and this is still a right-angled triangle. So to calculate r, we have that r is equal to square root of minus 1 squared plus root 3 squared minus root 3 squared in this case. And we already know that r must be equal to 2 from the other calculation. Now, this is the angle that we are looking for, this big theta. But we can calculate this one. Once more, let us call it alpha. And we know that tan alpha is equal to, remember here is still root 3 and here is still 1. Root 3 over 1. And alpha is equal to tan inverse of root 3. And this is still equal to 60 degrees. But in this case, we now have that theta is equal to 180 degrees plus 60 degrees. So we have that theta is equal to 240 degrees. So we have that y in its polar form is equal to 2 into cos 240 degrees plus I sine 240 degrees. Next, when we have a complex number z that is equal to r into cos theta plus I sine theta, this man I never know how to pronounce this, please forgive me. But this person, this French person, told us that to get z raised to power n, that all we have to do is raise r, the modulus of the complex number, to power n, and then multiply the argument by n. So basically we have cos n times theta plus I sine n times theta. So now you see why I said that the simpler way of doing this is to change the complex number to its polar form and then use this man's theorem. So what we simply do to raise y to power 4 and to raise x to power 4 is to raise 2, their modulus, to power 4 and multiply the arguments by 4, which is quite simple. So here we have that x raised to power 4 is equal to 2 raised to power 4 is 16. And 120 times 4 is 480. So we have cos 480 plus I sine 480 degrees. And here we have that y squared is equal to once more 16 because 2 raised to power 4 is 16. Cos 240 times 4 is 960 degrees plus I sine 960 degrees. So all that we have to do now is to evaluate this and add. So here we have that this is equal to 16 into cos 480 is minus half plus sine 480 is root 3 over 2. Yes. And in this case, we have 16 into cos 960 is still minus half. And sine 960 is minus root 3 over 2. So all that we do at this stage is to evaluate this and add. So we have that x squared is equal to 16 times minus half is minus 8 plus 16 into root 3 over 2 is 8 root 3i. And y squared is equal to 16 times minus half once more is minus 8. And 16 into minus root 3 over 2 is minus 8 root 3i. And adding these two, we have minus 16 plus this plus minus this is 0. That takes care of that. So we have that the value of this is equal to minus 16. And that is the end of the first method. Now we go over to the second method. Now in the second method, we do not have to calculate the particular values of x and y. What we do is to work with the expansion of x raised to power 4, or rather work with the expansion of x plus y raised to power 4. Now we already have a value for x plus y and it is minus 2. The next thing we need to find a value for is x, y. We have a value for the sum of x and y. So we need a value for the product of x and y. And we will get that from this fellow. So here we have that x plus 3, or rather x plus y raised to power 3 is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. Now we collect terms. We have that this is equal to x cubed plus y cubed. We can factorize this. We have that this is 3xy into, when you do 3x squared y divided by 3xy, you have x. And when you do 3xy squared divided by 3xy, you have y. Now we have a value for this which is minus 2, so we have minus 2 cubed. Here we have a value for this. which is 16. So we have 16. We have 3xy, and of course this is minus 2. So we have that, very important, minus 2 raised to power 3 is minus 8 is equal to 16 minus 2 times 3 is minus 6xy. We have that minus 8 minus 16 is equal to minus 6xy. We have that minus 24 is equal to minus 6xy. Dividing both sides by minus 6. This takes care of that, and we have that xy is equal to 4. We have that xy is equal to 4. Now we go over to the expansion of x plus y raised to power 4. And this is equal to x raised to power 4 plus 4x raised to power 3y plus 6x squared y squared plus 4x y cubed plus y raised to power 4. Collecting terms once more, we have that this is equal to x raised to power 4 plus y raised to power 4 plus, now we know that this is equal to 6xy squared, and we can factorize this too. We can bring out xy. So now when 4x cubed y is divided by 4xy, what we have is x squared. And when 4xy cubed is divided by 4xy, what we have is y squared. But now look at this. We know that from the expansion of x plus y squared, which is equal to x squared plus 2xy plus y squared, we know that x plus y squared minus 2xy is equal to x squared plus y squared. So we can replace this with this in this expansion. So ultimately we have that x plus y raised to power 4 is equal to x plus y plus 6xy squared plus 4xy into x plus y squared minus 2xy. Now all that is left is to substitute these values into this. Remember that this is what we are looking for. So here we have x plus y is this, minus 2 raised to power 4 is 16, and this is equal to x raised to power 4 plus y raised to power 4 plus 6. Now xy is 4, and 4 squared is 16. So 6 times 16 plus xy is 4. 4 times 4 is 16 into x plus y is minus 2. Minus 2 squared is 4 minus xy is 4. So 2 times 4 is 8. So here we have that 16 is equal to x raised to power 4 plus y raised to power 4 plus 6 times 16 is 96 plus, now we have 16 times 4 minus 8 is minus 4. So we have that 16 is equal to x raised to power 4 plus y raised to power 4 plus 96. Because of this, we have minus 16 times 4 is 64. So we have that 96 minus 64 is equal to plus 32. Taking this over to the left-hand side, we have that 16 minus 32 is equal to x raised to power 4 plus y raised to power 4. So minus 16 is equal to x raised to power 4 plus y raised to power 4. So we see that we get the same answer, negative 16 for this value. This has been a rather long one. I hope you enjoyed the class. Like I said at the beginning, please, if you know any simpler and shorter way of doing this, do let me know in the comment section. If you enjoy content such as this, don't forget to subscribe, share the video, and leave a like to support the channel. Thanks for watching and see you in the next one.